So let's look at this problem where again how to apply the Newton's law correctly will become more clear. So let's say figure 2.52 shows a person in an elevator pulling a rope that goes over a pulley and is attached to the top of the elevator, right? So he's pulling the rope like this, which is attached to the top of the elevator, right? The mass of the elevator is 30 kilograms. So this elevator, the whole elevator, right, is 30 kilograms. And the person is weighing 70 kilograms. Okay, and the G we have to take as 10 meter per second square. Draw the forces on the person. Okay, so first we have this person. In order to draw the forces, we have to see where this person is touching anything. But first, we'll have the mass of the man, right? Mg going down, right? Which is going to be 70 kilograms. So this is going to be 700 newtons downward. Okay. Now the person is touching over here to the elevator, so it will experience a normal force upward by the elevator. Second, he is pulling the string, so he is going to get another tension force, right? Like that, right? So he'll pull and the spring is going to pull him upward. These are the three forces only which is going to act on the man, right? The normal reaction from the bottom of the elevator, the tension force, and mg, like that. Okay. Now says part B, draw the forces on the elevator. Okay. So when we look at the forces on the elevator, this is the bottom of the elevator, right? And then the elevator is attached here, over here with a string, right? So this is going to get pulled by that string upward, right? Also the mass of the elevator is there. So I'm going to write a capital M, G. Mass of the elevator is 30. So this is going to be 300 newtons. And the normal reaction from the man, right? So elevator is pushing the man upward. The man is also going to put him down with the same normal reaction, right? So this is the pair for the Newton's law, and this is the pair for the Newton's law 3 for the tension. Okay. So that is that. So we have done the free body diagram. Part C, the elevator accelerates upward at 0.5 meter per second, which is half a meter per second. Okay. And we have to find the normal force on the person from the elevator to the floor, right? So we have to find m is equal to what when the elevator is accelerating upwards, okay? Because the man is also there in the elevator, both of them are actually going to accelerate upward with the same A, okay? Both of them are actually accelerating upward with the same A. Try to visualize that because the rope is slipping in his hand. And now because the elevator is accelerating upwards, we cannot apply F equal to ma in the elevator's frame of reference, okay? We have to come down to the earth, which is our inertial frame of reference, right? So the Newton's law cannot be applied in a non-inertial frame, right, or accelerating frame. So we have to apply the Newton's law in the inertial frame from the earth. If you look from the earth, both of them are accelerating upward with an acceleration A, and these are the forces which is acting on them, okay? With that in mind, we are going to now write our equations to find the value of n given the value of A is equal to half meter per second square, okay? So it is going up for the elevator. We are going to write the first force is tension, which is going upward, okay? So T minus two forces N and mg. So T minus N minus what is the value of mg? 300 newtons, right? So 300, that is going to be equal to the mass of the elevator. Mass of the elevator is 30. So 30 A, right? That is our equation number 1, okay? Now we look at the man. He is also accelerating upwards, right? Because he is in the elevator. So look at the forces. So we are going to start from the positive side. So N plus T, right? So N plus T. And then we have this gravitation, which is minus 700. Minus 700. And mass of the man is given to be 70 A. That is our equation number 2. Now, which are the unknowns? We have unknown T, N, and A. Because the A is now given, we only have two unknowns, T and N, and we have two equations, so we should be able to solve it. We are not interested in the tension, right? We have to find the normal reaction first. So what we can do is that we can eliminate the tension, right? So for eliminating the tension, what we can do, we can just take this equation down with a minus sign, right? So we are going to take this equation down with a minus sign, so this will become minus t. Now this minus will become plus, this minus will become plus, and this will become minus 38, right? And then we add them up. So we get 2n, then this dt will cut, right? So we are subtracting there, right? With minus, plus, plus, and minus, okay? This is 2n. That is going to be equal to minus 700 plus 300, okay? So 2n minus 400 is going to be equal to 40a, and there's a value of a which is 1 by 2. This is going to be 40 into 1 by 2. This is 20. Okay, so my equation is 2n. This 400 will go on that side, so this will become 400 plus 20. That is going to be equal to 420. Normal reaction value will be 420 divided by 2. That is going to be 210 meters. Okay, so we got our normal reaction N, which is 210 Newton. We'll check again. N plus T minus 770A is to the minus. This minus plus, and this minus plus, and this will come minus. So 2n minus 400 is equal to 40a. 40a is equal to 20. So 200 plus 400, 420. So that is correct. Okay. Now part D, the force on the person exert on the elevator floor is 200. Find the acceleration. So other way around we have to do now, assuming that the acceleration is not known. Okay. So we'll take these original two equations, and now we are saying the acceleration is not known, the n is known. Okay. I'm just going to copy that. So t minus n minus 300 is equal to 30a. Equation number 2, n plus t minus 700 is equal to 78. Okay. So t minus n minus 338, n plus t minus 778. Now we have to find a is equal to what, and n is given now to be 200 newtons. That's fine. So n is 200 newton. Now this time, again, we don't want the tension, so we have to again subtract. So let's directly subtract and see what happens this time. We directly subtract, so it will become plus or minus. Okay, so this will become plus t minus t. This t will go, and this minus 2n is going to be equal to 400. That is going to be equal to minus 40a. Okay, I take it on the other side to make it positive. 40a is going to be on that side. This will become 2n minus 400. Okay, that n is given to be 200, so I'm going to substitute over there. This will become 400 minus 400, and that is going to be 0. And my acceleration here now coming out is to be also 0, right? So if the normal reaction is actually 200, my acceleration is going to be equal to 0, and that will be our answer.